Hey guys, we did our project on Six Sigma. I'm Scott.
I'm Nick.
I'm Greg.
And I'm Nina.
What is Six Sigma? Six Sigma is a data-driven approach used to enhance business organizational operations by reducing defects in many processes of a company from manufacturing to servicing to end users. The sigma represents the standard deviation of a sample, which is how close the outcome is from the desired result. The 6 represents the number of standard deviations from the center of a bell curve, which includes 99.9997% of the data within the dataset. The method defines defects as any process that generates an outcome deviating from the customer's expectations and limits them to 3.4 per million opportunities.
There are two methodologies used in Six Sigma. The first is DMAIC and is implemented on current processes. The first step is to define the situation. This involves understanding the customer's expectations, the project goals, and the desired end product. The next step is the measurement phase, where data is collected, employees validate measurement systems, and determine the capability of the process. The analysis phase involves breaking down the manufacturing process to determine the root causes of the defects and any variation in the system. The improvement phase involves experimentation with control variables until inconsistencies are found and customers' expectations are exceeded. The last phase is the control phase, which involves modifying policies, procedures, and other management systems to prevent the problem from reoccurring in the future. The other methodology is called DMA-DV, which involves the same 3 stages and 2 different last phases, and is involved in the introduction of new processes. The design phase involves ranking the new solution components and creating a prototype model to identify errors in improved processes and making necessary adjustments. The verification phase involves validating the new design through production runs to ensure that the outcome exceeds the company and customer standards.
Advantages of Six Sigma. The first obvious advantage of Six Sigma is its reduction of many defects along the manufacturing process that benefits customers, employees, and shareholders. Six Sigma is ideal for companies that rely heavily on precise quality control, such as car manufacturers and healthcare technology companies. These companies have very tight tolerances on precision of their product, since end user safety is the #1 priority. It is a customer-driven method since it defines any product not accepted by the end user as a defect, making customer satisfaction a very important factor. Finally, the implementation of Six Sigma can lead to great operational and financial improvements. For example, Motorola reported savings of $16 billion and GE reported savings of $10 billion by implementing Six Sigma. Disadvantages of Six Sigma. Although Six Sigma is a proven method to improve operational efficiency, there are still some drawbacks that make it unsuitable for certain companies. First, it involves high costs of training, which may be a major drawback for small companies with tighter budgets. It has a very strong emphasis on the rigidity applied to all aspects of the production and planning processes. Some believe that this can hinder creativity and innovation within the company. Finally, it involves well-defined methods of communication, inventory control, and customer service that require full commitment from the entire staff, which may be difficult for large companies.
So as far as the application for our project, we decided that we would be managing an automotive manufacturing company that designs car bodies by sheet metal bending. The first step in applying Six Sigma principles to the manufacturing process is to define the issue. When it comes to sheet metal bending, 2 of the biggest defects that occur are fractures and wrinkling in the metal. The next step would involve measuring the problem and quantifying it by looking at the amount of part defects that occur and must be thrown away. In analyzing the problem, we find that initial sheet thicknesses are the root cause of the issue. In order to improve the process, we propose a solution of installing a laser measuring device that looks not only at the thickness of the sheet at one point, but runs across the entire sheet to ensure a uniform thickness. Since thin sheets cause fracturing and thicker sheets can cause wrinkling, this measuring device will minimize defects to an acceptable level. Finally, we must control the new process by a cost-benefit analysis and ensure that we are not wasting money on this method. While Six Sigma is not suitable for all companies, we can confidently say that it is a perfect fit for us due to our large production volumes and high metal costs that need to be minimized. And here is our works cited page. Thank you for listening.